let us revise the concepts of conjugate points and conjugate lines that we have discussed yesterday. So, to understand the concept briefly, so we have already discussed in the concept of pole and polar. So, if the point P lies outside the circle, the polar cuts the circle at two distinct points. And if the pole lies inside the circle, the polar neither cuts nor intersects the circle. So let us suppose that line is this. Okay. Now listen. So here this point is Q, I suppose. Very first, at the outset, I just wanted to tell you, pole means point and polar means it's a line. So let us suppose that the point P lies outside the circle. Then the polar of this point P, that means it is pole. P is what? P is a point or pole. So, since it is a pole, it needs to have a polar. So, that polar is this line. Okay. So, and if Q lies inside the circle, the polar of P, the polar of Q lies outside the circle. Now, P comma Q points are said to be conjugate points if the polar of this point P passes through Q. What is this line? This line is the polar of the point P. So, the point P's polar is this, and this is passing through Q. And as far as Q is concerned, Q is a point. In other words, it is a pole. Since it is a pole, it has to have a polar, and that polar is, for example, this. The polar of the point Q is this, and this polar of Q is passing through P. Therefore, the points P comma Q are said to be conjugate points because the polar of P is passing through Q and the polar of Q is passing through. The polar of Q means this line. This is passing through P. And now conjugate lines. Conjugate lines. For example, this is L1 equals to 0 and this is L2 is equals to 0. The lines L1 and L2 are said to be conjugate lines if the pole of this L1 equals to 0. So this is a line. So if it is a line, it has to have a point, right? So for this L1 equals to 0, the pole lies on, the pole of this L1 equals to 0 lies on L2 equals to 0, and the pole of L2 equals to 0 is P, that is lies on L1 equals to 0. Then the lines L1 equals to 0 and L2 is equals to 0 are said to be conjugate lines. Now the next theorem is the equation of the pair of tangents is S1 square is equals to S into S11. So these are the pair of tangents. So proof, let S be x square plus y square plus 2gx plus 2fy plus c equals to 0. Let px1 comma y1 be an external point. Be an external point. So through P, draw tangents which meet the circle, which meets the circle at A and B. So then AB is the chord of contact. What is chord of contact? So equation of this chord of contact is S1 equals to 0. That is xx1, that is xx1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c equals to 0. Now, see, AB is the line. Chord of contact is the line itself. So this line divides PQ in the ratio. AB divides PQ in the ratio minus S11 is to S12. How can we say? Because remember what we have discussed last year. See, for example, this is the line L, AX plus BY plus C equals to 0, and this is P, X1, Y1, and this is Q, X2, Y2. So the line L divides PQ in the ratio minus L11 is to L22. L11 in the sense, substitute X1, Y1 in this. AX1 plus BY1 plus C. So what is L22? Substitute simply X2, Y2 in this. AX2 plus BY2 plus C. So here L is the chord of contact AB. So this also we can arrange in a equation of a line. How? Xx1 plus Gx, x into x1 plus G, y1 plus fy, y into y1 plus f, plus gx1 plus fy1 plus c. So x into x1 plus G, x plus y into y1 plus f, y plus gx1 plus fy1 plus c. This is of the form ax plus by plus c equals to 0. So if you substitute this x1, y1 in this, let us see what will happen. Substitute. What is minus L11? Substituting x1, y1 point in this. Likewise, substitute x1, y1 point in this. Then see, x1 into x1, x1 square, y1 into y1, y1 square, g into x1 plus x1. So 2gx1. So f into y1 plus y1, 2f y1. So what we are getting? X1 square plus y1 square plus 2gx1 plus 2fy1 plus c. If we substitute 1, 1 in this line equation, S11 is what we are getting. Is to L22, substituting x2, y2 in this. Here, substituting x2, y2 in this line AB. So substitute x2, x1 plus y2, y1 plus g into x2 plus x1. Substituting this x2, y2 in this line. So x2, x1 plus y2, y1 plus g into x2 plus x1 plus f into y2 plus y1 plus c. What is this? S21 or S12? Both are same. Now, PB by BQ is equals to minus S11 by S12. What is PB? PB is the length of the tangent from Px1, y1 to this circle. So this is root S11. What is QB? Length of the tangent from Qx2, y2 to this circle. This is root S22. So therefore, this is PB means root S11 by BQ is S22 is equals to minus S11 by S12 implies squaring on both sides S11 by S22 is equals to S11 square by S12 square. So this and this gets cancelled. That implies S12 square into 1. S12 square is equals to S11 into S22. S11 into S22. Therefore, this locus of Qx2, y2 is, see, in first year the locus of P, so y1 square equals to 4x1, for example, we used to get that. So the locus of Px1, y1 is simply replacing x1, y1 by x and y. That was the answer. Here, instead of x1, y1, we need to replace by x2, y2. Simply, we used to remove ones earlier. So we need to remove 2's here. So S1 square is equals to S into S11. So S1 square is equals to S11 is the equation of this pair of tangents. Let's discuss inverse points. So inverse points. So let S is equals to 0 be the circle. With the center C and radius R. 2 points P comma Q are said to be inverse points if it has to undergo 3 conditions. What are they? First, C comma P comma Q are collinear. That means all these 3 points must lie on the same line. Second, the points C comma P comma Q lies on the same side of the line, same side of the center, and CP into CQ is equals to R square. So for the 2 points to be inverse points, it has to they have to undergo all these 3 conditions. So for example, let let P is the point lying external to the circle. So if P is a point lying outside the circle, the polar cuts the circle at 2 distinct points. For example, this is the polar. This is the polar. What is this? This is the polar. So if I join this P and C, if I join this P and C, then this point Q is called the inverse of the point P. So here P comma Q are lying on the same side of center of the circle. It is not like so if P is this and C is this, Q is not should not lie here. So P comma Q should be lying on the same side of the center of the circle, and Cp into Cq is equals to R square. Then those points P comma Q are said to be inverse points. So these are the 3 points. Let P comma Q be a pair of inverse points. P comma Q are the pair of inverse points with respect to circle S is equals to 0. If P lies inside the circle, so actually this is first condition. P lies outside the circle. Q, the inverse of P, lies inside the circle. What is this condition now? If P lies inside the circle, then Q lies outside the circle. Because if P lies inside the circle, the polar of P neither cuts nor intersects the circle. So polar will be formed here. Okay? The polar will be formed here if the point P lies inside the circle. That means if P lies inside the circle, the polar will be here on that. So Q will lie. Therefore, if P lies inside the circle, Q lies outside the circle. And if P lies on the circle, then both P and Q coincides with each other. If P comma Q are pair of inverse points, P is said to be the inverse point of Q and Q is said to be the inverse point of P. And the inverse point of P with respect to the circle S is equals to 0 is always unique. So the theorem is, let S is equals to 0 be the circle with center C and radius R. The polar of a point P with respect to circle S is equals to 0 meets Cp in Q if PQ are inverse points with respect to S is equals to 0. Proof. Suppose the polar of P with respect to circle S is equals to 0 meets Cp at Q. So that means if P is the pole, the polar of this is this line and this line meets Cp, or this line cuts Cp at Q. That's what I have written. So let the circle be x square plus y square plus 2gx plus 2fy plus c equals to 0. So the center of the circle, this is minus g comma minus f, and radius r is equals to square root of g square plus f square minus c. So the polar of P with respect to the circle S is equals to 0 is S1 equals to 0. What is S1 equals to 0 for this? X1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equals to 0. So if you put it in an order, so x1 plus gx, take x in common, x1 plus g plus y1 plus fy, take y in common, y into y1 plus f plus what is remained? Gx1 plus fy1 plus c. So gx1 plus fy1 plus c equals to 0. So what is this? This is nothing but this we have derived from this only. And what is this? The polar of P. The polar P is the point. The polar means it's a line. Line is of the form ax plus by plus c equals to 0. Yes, ax plus by plus c equals to 0. So therefore, let the slope of the polar be m1. So what is the slope of ax plus by plus c equals to 0? Minus a by b minus x coefficient by y coefficient. So minus of x1 plus g by y1 plus f. And let the slope of CP be M2. So M2 is equals to, so P point is x1 comma y1. So C is minus g comma minus f. So when 2 points are there, what is the slope? Y2 minus y1 by x2 minus x1. Difference of ordinates by difference of abscissa. So y1 plus f by x1 minus of minus. So x1 plus g. So if we notice here, m1 m2 equals to minus 1. m1 m2 equals to minus 1. See, this and this, if you multiply, x1 plus g gets cancelled, y1 plus f gets cancelled, we are left with the minus 1. If the product of the slopes are equals to minus 1, then what do you say? So CP is perpendicular to the polar. Therefore, CP is perpendicular to the polar. So that is what we need to prove. See, the polar of point P with respect to s is equals to 0 meets CP. Okay. Now, so CQ is the perpendicular distance from the center to the polar PQ. So the polar of P, that means minus g minus f. And what is the polar of P? S1 equals to 0. This we have rearranged before. X into x1 plus g, it is of the form ax plus by plus c equals to 0. Okay. So now CQ is the perpendicular distance from the center of the circle to the line. What is the perpendicular distance from the point P x1 y1 to the circle to the line ax plus by plus c equals to 0? Modulus of ax1 plus by1 plus c by square root of a square plus b square. So in the x1 plus g into minus g. So minus g into x1 plus g plus minus f into y1 plus f minus f into y1 plus f plus gx1 plus fy1 plus c by modulus by square root of the quotient of x plus square root of the quotient of y. So x1 plus g whole square plus y1 plus f whole square. Remember, the perpendicular distance from P x1 y1 to the line ax plus by plus c equals to 0 is, that is, this is the line ax plus by plus c equals to 0, and this is the point P. So this is the perpendicular distance. P x1 y1 is modulus of a x1 plus b y1 plus c by square root of the quotient of x a square plus square of the quotient of y b square. Same way I have applied also. A x plus by plus c equals to 0. This is x1 y1. So this is equals to minus gx1 minus g square minus fy1 minus f square plus gx1 plus fy1 plus c by square root of x1 plus g whole square plus y1 plus f whole square. So minus gx1 plus gx1 minus fy1 plus fy1 gets cancelled. So modulus of minus of g square plus f square minus c, minus I have taken common, by square root of x1 plus g whole square plus y1 plus f whole square. It is CQ. So that implies CQ is equals to modulus of this g square plus f square minus c by this is x1 plus g whole square plus y1 plus f whole square. So this is equals to CQ is equals to what is the radius? R equals to square root of g square plus f square minus c. R square is g square plus f square minus c. Therefore, this value is r square by x1 plus g whole square plus y1 plus f whole square. x1, y1 and c. The distance between CP. That means this is CP. Therefore, CP into CQ is equals to r square. Therefore, these are the points that we have noticed. What is that? What are they? P comma Q are the inverse points with respect to S equals to 0. Then P comma Q are conjugate points with respect to S equals to 0. P comma Q are said to be inverse points with respect to circles. Then P comma Q are conjugate to each other, because what are conjugate points? P comma Q are said to be conjugate points if the polar of P, if P is the point, then its polar will be this. The polar of P passes through Q. Okay? And if Q is the point, then the polar of Q is this line, and this line is passing through P. Then then P comma Q are said to be conjugate points. Therefore, the inverse points are said to be conjugate points. If P comma Q are inverse points with respect to S equals to 0, then Q is the foot of the perpendicular from P on the polar of P with respect to circle. So, Q is the foot of the perpendicular from the point P on this polar. Or the Q is also the foot of the perpendicular from C, the center of the circle, to the polar. Of course, here it is not mentioned, but Q is the foot of the perpendicular of P on the polar, and also Q is the foot of the perpendicular of the center C on this polar. And the third point is the polar of a point P with respect to S is equals to 0 with center C is perpendicular to CP. That's what we have discussed. So the polar is perpendicular to the line joining of P and C, CP. Now the next question, next theorem is midpoint of a chord. So let S is equals to 0 be the circle. Let AB be the chord, and P point x1, y1 is given. Then the equation of this chord AB is S1 equals to S11. So proof of this is, let S circle be x square plus y square plus 2gx plus 2fy plus c equals to 0. Then center of this is C is equals to minus G comma minus F, and radius is equals to square root of G square plus F square minus C. So let us find the slope of CP. Slope of CP. So 2 points are there. So difference of Ordinates by difference of abscissa. y2 minus y1 by x2 minus x1. y1 minus of minus. So y1 plus f by x1 plus g. Therefore, CP is this is the slope of CP. Then what would be the slope of AB? Slope of AB is equals to, what is this AB? Chord. Chord. So that should be minus of x1 plus g by y1 plus f, because this CP is perpendicular to AB. CP is perpendicular to AB because this is the chord, and this is always passing through the center of the circle. That means this is the normal. Okay, then CP is perpendicular to AB. Now, therefore, equation of the chord AB, because that is what we are required to find, having px1 y1 as its midpoint, the equation of the chord. So this equation of the chord we want. So we have the slope of AB. Okay, we have the slope point form. Y minus y1 equals to m into x minus x1. So y minus y1 is equals to, because this is the line passing through P, and it is having the slope which is minus of x1 plus g by y1 plus f. So minus of x1 plus g by y1 plus f into x minus x1. So if you cross multiply y minus y1 into y1 plus f is equals to, this minus term if you bring here, so x1 plus g into x minus x1 equals to 0. So this is y1 y into f fy plus x1 into xx1 plus g into x gx is equals to, this is minus y1 square. If you take that side, y1 square. So here minus y1 f, if you bring to that side, fy1. Next, this is x1 into minus x1 square. If you take to this side, x1 square. So g into minus x1 minus gx1, if you bring to this side, plus gx1. So adding gx1 plus fy1 plus c on both sides. Then xx1 plus yy1 plus gx plus gx1. So g into x plus x1 plus fy plus fy1 f into y plus y1 plus c, this is LHS, is equals to x1 square plus y1 square plus gx1 plus gx1 2gx1 plus fy1 plus fy1 2fy1 plus c. So now what is this? xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c. This is S11 is equal, this is S1 notation is equals to, this is S11. Therefore, the equation of the chord with the P midpoint x1 y1 is given is S1 is equals to S11. So points to ponder. So the equation of the uh, chord of contact. Sorry, cut कर दल फिर भी first. Let us discuss the points so far we have covered. So the equation of the chord of contact of P with respect to of P x1 y1 with respect to circle S equals to 0 is S1 equals to 0. The equation of the polar of P x1 y1 with respect to the circle S equals to 0 is also S1 equals to 0. The equation of the tangent at P x1 y1 with respect to circle S is equals to 0 is also S1 equals to 0. For all these three, S1 equals to 0, but the point is different, which we have discussed before. And the fourth one, the pole of the line Lx plus My plus n is equals to 0 with respect to the circle x square plus y square equals to r square is minus lr square by n, comma, minus nr square by n. The pole of the line Lx plus My plus n equals to 0 with respect to the general equation of the circle x square plus y square plus 2gx, this I will write here, with respect to s x square plus y square plus 2gx plus 2fy plus c equals to 0 is minus g plus lr square by lg plus mf minus n, comma, minus f plus mr square by lg plus mf minus n. The condition for the points P x1 y1 and Q x2 y2 equals to 0 with respect to the circle S is equals to 0 is S12 equals to 0. Then two lines L1x plus M1y plus N1 equals to 0 and L2x plus M2y plus N2 equals to 0 or conjugate with respect to the condition that the two lines L1x plus N1y plus N1 equals to 0, L2x plus M2y plus N2 equals to 0 or conjugate with respect to circle x square plus y square is equals to r square is r square into L1 L2 plus M1 M2 is equals to N1 N2. So the condition that the two lines L1x plus M1y plus N1 equals to 0 and L2x plus M2y plus N2 equals to 0 with respect to circle S, x square plus y square plus 2gx plus 2fy plus c equals to 0 is r square into L1 L2 plus M1 M2 is equals to L1g plus M1f minus N1 into L2g plus M2f minus N2 equal N2. So the equation of the chord having midpoint P x1 y1 having its midpoint P x1 y1 is S1 is equals to S11. The equation of the pair of tangents drawn from an external point P x1 y1 to the circle S is equals to 0 is S1 square is equals to S into S11.